Hello everyone, this is Sykes Music Studio. Today we're going to continue working on our sequencer patch. As you can see, we've opened in presentation mode. This is the mode that your end user is going to see. To switch from presentation mode to patching mode, you can click this icon in the bottom left here. If you'd like to open your patch in presentation mode, you can either right-click and select Inspector window, or use this hotkey Control-Shift-I. You'll scroll to the bottom and check Open in Presentation. Now you'll want to work on your presentation mode early so that your interactable objects have a logical flow to them. Let's take a look at what we have so far. We have our on-off toggle in the top left, our reset button just below it. We have our key selector here. And then we have our loop option. So we can loop our melodies and rhythms together or individually. Now we're also going to want to lock these individual options while loop together is selected, but for now it works just fine. And then we have our parameter controls for our loops. So how many unique pitches per loop do you want? And then how many repetitions of that loop do you want? Same thing with rhythms. How many unique durations do you want? And how many repetitions of that loop? So let's just play around with it. Let's create some beautiful music, and then we will hop into our patch. All right, so right off the bat, it's sounding a lot more musical than it did last week. It still has quite a ways to go, but let's find out what we've done so far. So right off the bat, we have our loop rhythms control here. It has a receive that's just receiving our loop together option. And this is just going to be used to control this gate. So this gate is determining whether our rhythms are random or looped. If they're random, it's going to send our metronome information or bang into this drunk object. Now, drunk is a really fun object. It's essentially a random number generator. However, once it receives an initial, or once it sends an initial output, it will only move with increments that you set for it. So because we have the default here, it's just going to move in increments of 1, or it's not going to move at all. And then we can go in here and set the increment maximum, and you'll notice that we are leaping all over the place now. The 16 here is just the range of the numbers that it can select. Now, we really only need increment 1 here because we're using drunk to pick our note values. So we really want to stick to note values that are close to each other. We don't want to have our half notes going back and forth to 16th notes because that's going to sound really chaotic and incoherent, which is ironic because we're sending it a drunk. But anyway, we're going to take the output from our cols, and you'll notice that because we're working with symbols, that it has a symbol tag associated with it, and we're just using ZL slice 1 to essentially cut this list in half, and then we're only taking the note duration and sending that to our metro. All right. Now, if we're going to loop our rhythms, it's going to send our metronome bangs out of our second output here. and that's going to go into this gate. We have it set to default 2, so it's going to send into this drunk and then into this toggle or trigger. Now remember, triggers are going to resolve from right to left. So the first thing that's going to happen is our integer is going to get packed into the cold inlet of our pack here. And then we're going to send a bang to this counter, and that's going to go into the hot inlet, which is going to result in our new list being sent to our coal. And that's going to pack our rhythms into this collection. And then we're going to, the last thing we're going to do is we're going to bang on this counter, and that is going to call up whatever we just packed into it. And that's going to be sent into our coal for rhythms. Now we're using our parameter controls to determine the set count maximum of our counters. This will allow us to use the third outlet here, the counter hit maximum flag. So if our counter reaches the maximum number, it will output a 1, and then we're going to check for whether these counters output 1 or not. And then we're going to do 2 things. One, we're going to change our gate from our second output to our first. This is essentially changing our output from write to read. So before we were writing our rhythms into this coal, and now we're just reading them. All we're doing is taking a bang to the counter, and it's going to loop what we have stored in the coal. The second thing we're doing is we are banging on this counter, and this counter is associated with the number of repetitions. So once this hits its maximum, we're going to route 1, and then we're going to start the process over, send a 2 to this gate, and then we're going to write new rhythms. So this is quite a bit more complicated than last week's video, but essentially we're just writing to the coal. We are reading from the coal, and then once we have written the number of notes that we want, it's going to switch from write to read. And then once it hits the number of repetitions we want, it's going to switch back. It's going to switch from read to write, and then we're going to start the process over again. Now, moving down our patch here, we have changed our random to an earn. Now, we're probably going to want to have a second random number object send into this random send. The problem here is that we are going to get a lot more of our lower number options this way because we have to modulus. Another option, we could just add more options, right? But it is making it so that the lesser options are going to be selected more often than the higher number options. But we are taking, the reason we have it set to 22 right now is we are sending that into our random send here and down into our octave selector. Now, before we talk about the octave selector, let's take a look at our gate here. We did change from 7 outlets to 8, and this is because we want our initial value to always be the tonic. So I just set it so that the first thing that happens is it's going to send a tonic, and then we're going to send it to our collection for what happens when we receive a tonic, and then it's just going to bounce as it should. Now, we are taking that random from our earn, and we're using this to control our octaves. Before, we had it set so that it was going to add the previous pitch to the equation, and we don't want that. We just want to send 7, 14, or 0, depending on the octave range. And that's why we're using this earn. So we'll figure something out here, but we do want to make it so that our options have even chance of being selected. So we'll play around with that in the future here. Another thing we're going to have to play around with is our leap resolution. So in classical music, if you leap greater than a fourth, you're going to want to resolve by moving by step in the opposite direction. So let's say you go from 1 to 5, then you're going to want to resolve to 4, typically. And that's what this is meant to do. So you can see that we are basically taking the previous pitch against the current pitch and then sending that into a trigger. And we're going to test, was this greater than a third or was it a greater than a third leap in either direction? If it was, then you resolve by step in the opposite direction. Now we're currently adding this to the note that it's selected and not the previous note. And what we're going to have to do is effectively override a new note with this information. Instead of subtracting or adding to the current note, we're going to subtract or add to the previous note and then just override whatever was supposed to go through. But hopefully this gives you an idea of where we're heading, and we will fix this a little bit more. We'll make it functional in our next video. Moving down. Oh, this is something I should have mentioned before. We have our colored objects here. Now, to color an object, you can just select that object, go to Objects, and then Color. And this is really, really useful when it comes to organizing your patch. So I use it to indicate objects that I'm using frequently. So sends and receives can go anywhere in the patch. So I want to be able to see them quickly and easily. Same thing with coals. You might be going in and out of a coal. Like I said, we're probably going to need to go into these coals at some point to either add options or even, for example, if we want to differentiate how pitches move to other pitches from minor to major, we are going to need to be going in and out of these coals. So it's good to be able to easily identify them. And then we have a new object here, P, and P is a patcher. So P plus name. And the way a patcher works is you can essentially store code into it and it becomes its own object. So if you select code and then use the hotkey Control-Shift-E, that will encapsulate that code into a patcher. And then if you control and double click on it, you can open it up and see that our code is nested in here. Now, we don't really need to use that for code like this. I mean, this is fairly small and simple and not really in the way or creating spaghetti noodles all over the place. But for big blocks of code where you have cables going that are feeding back into other cables and going all over the place, it makes a lot of sense and it just cleans up the patch quite a bit. Now, the patcher we're currently in is our loop melodies patcher, and you'll notice that the code is very, very similar to our loop rhythms patcher or loop rhythms code. The only difference is we have removed the drunk object because we don't want our pitches to only be able to move by step, or worse, just stick on the same pitch over and over. And then we've changed the name of the coal. But really, it's basically the same principle. We're just writing until we have reached the count maximum. And then we are reading until we have reached the repetition maximum. And then we will go back to writing new melodies. Finally, we have our velocity and duration controls here. Now, sine and cosine is kind of arbitrary. You can use whatever you want to ensure that these numbers are different. Maybe we'll have two randoms going into this, so like a random and then a random 2. But for now, I'm just using sine and cosine to get different output. Now, sine and cosine have a range from -1 to 1, so I'm multiplying the output by 90. I am taking the absolute value so that if it's -90, it becomes 90. Just in case something weird happens, I have a modulus here so that it doesn't exceed the maximum. And then I have a floor. So the minimum value is going to be 32. The maximum is going to be 122. Now, the actual maximum is 127. I just figure keep it a little bit lower because it's much harder to fix something that's clipped than it is to increase the volume of something that is a little too quiet. And that's where we are so far. So, again, quite a bit of progress since last time. In the next episode, what we'll do is we are going to fix what needs to be fixed here. We're going to flesh out our random number sends. We're going to make sure that our octave control is functioning. We're going to make sure that our extreme leaps checker is functioning. We will clean up the patch. So I'm going to encapsulate all this stuff. And then we'll work on new stuff. We'll add a meter control. We'll differentiate how our pitches move from major to minor. We'll add some new keys or a key selector so that our tonic isn't always the same tonic. We'll keep working on it and keep working to make it more and more musical. And I appreciate all of your support and feedback. If you have any questions or comments for me, please leave them in the comments below. And I will see you next time. Thanks. Bye.